Bismillahirrahmanirrahim. So far we have studied how vectors can be differentiated and how they can be integrated. We have done three types of integrations: line integration, surface integration and volume integration. Then based on integration there are two very important theorems. One of them is Stocke's theorem, which interrelates the line integral into the surface integral. Line integral into the surface integral. If you look at the left hand side, A is a vector which is defined over a surface S, and S is bounded by a curve C. Surface S is bounded by a curve C. Then in that case, if you take curve of that vector, integrate over the surface S, answer will be the same if you integrate vector itself around the path C. Okay? So what is the statement of the theorem? It says that line integral of vector A over the closed path C, which encloses the surface S, is equal to curl of vector A over the entire surface which is bounded by the curve C. Okay, so that is the statement of the theorem. Let me repeat it. The line integral of vector A around the simple closed curve C is equal to the surface integral of curl of A over the surface S, having C as its boundary. That is the statement of the theorem which interrelates the line integral with the surface integral. We are not going to prove it. This is left for mathematician to do. Now we come to how this theorem works in solving the problem of physics. Okay, I am going to take an example of this, and this is problem number 6.10, page 180, Advanced Mathematics, the book which you have, and it says verify Stocke's theorem for A is equal to, A is a vector, 2yi plus 3xj minus z square k, where S is the upper half surface of the sphere whose equation is x square plus y square plus z square is equal to 9, and C is its boundary. He is saying sometime vector is given and he says calculate this, or he will say calculate that. Then it is up to you which side you are going to calculate it. Whatever looks to you easy, do that. Either calculate that or that. But this says verify Stocke's theorem. It means that you will calculate this portion and then you will calculate this portion. The left hand side will be equal to right hand side, the theorem will be proved. But if he says evaluate this, if instead of writing that thing, if he says evaluate this for that, then you calculate only this part, or you can use that as well, because theorem says that. Okay, you have to calculate only one side. Or if it is given, okay, calculate this integral, so it's up to you if you can calculate this portion, or you can use that side. But if it says verify Stokes theorem, you have to calculate both sides. Okay, so let's look at the figure first. This is your x, y, z coordinate axis in 3 dimensions. And now look at the statement. S is the upper half surface of a sphere. X square, y square, z square is equal to 9. So this is a sphere whose origin is at 0. So that is the, okay. But he is saying the upper half surface. He is talking about the upper half surface, not the lower half surface. So we will erase lower half surface, that is not needed. Okay, this surface is not needed. Alright, so that is the upper half surface of this sphere, and its radius is 3, because you have to take a square root. Radius is 3 unit. Okay, radius is 3 unit, and that is its lower portion, and C is its boundary. C is the boundary of that is C. Okay, you are moving around that, which will be a circle of radius 3. Okay, so let's calculate the right hand side first. Right hand side is equal to closed integral C A dot dr, and that will be equal to closed integral C. For A I am writing 2yi plus 3xj minus z square k dot dxi plus dyj plus dzk. Alright, this we have done before. Now what will happen? This I dot I is 1, I dot j is 0, I dot k is 0, so you will be having 2y into dx. Then 3x, j dot I 0, j dot j 1, so you will be having 3x into dy, and similarly j dot k is 0. And if you multiply this with that, k dot I is 0, k dot j is 0, k dot k is 1, so you will be having minus z square dz. So the answer to this is closed integral C 2y dx plus 3x dy minus z square dz. Okay, and now here we are, because it is over C, C is there, we are in xy plane where z is 0. In xy plane z is equal to 0, so z is equal to 0 in xy plane. Xy plane, in xy plane z is equal to 0, and therefore this integral reduces to C 2y dx plus 3x dy, sorry, this is dz. Okay, and that it means that is simplified. That is simplified. 2y dx, and then it is now. In order to solve this, it is easy to use parametric equation, because you know radius of this circle is 3. So you can take the polar coordinate. You can say let x is equal to r cosine theta and y is equal to r sine theta, and then that is, well, how much is r? R is equal to 3, so x is equal to 3 cosine theta and y is equal to 3 sine theta. So instead of writing theta, you can also write t. You can write cosine t, sine t, okay? So that is simple. And therefore this will give you dx is equal to minus 3 sine t dt. I have differentiated it. Dy is equal to 3 cosine t dt. We'll substitute this. X is equal to r cosine t, y is equal to r sine t, dx dy right here, and therefore this integral is closed integral r. Let's write it just integral sign. Now see, 3 cosine t, y is equal to 3 sine t. So 2 into 3 sine t into dx into minus 3 sine t dt plus 3 cosine t, okay, into dy, which is 3 cosine t dt. Now, what about the limit? What about the limit? Since you are moving from here to this circular path, so your limit is 0 to 2 pi, that is full circle. Okay? So your t is running from 0 to 2 pi because you are moving around a circle, and therefore what I'll get is 9 minus 18 sine square t dt plus 3 9 27 cosine square t dt. Okay, so that is that one. You can further simplify this. You can further simplify that by, okay, I'll be writing, I don't need that, okay, so I'll come here again, and therefore close integral c a dot dr is equal to minus 18 0 to 2 pi sine square t dt plus 27 0 to 2 pi cosine square t dt. Solve them. What you will get it is equal to minus 18 t over 2 minus sine 2t over 4 0 to pi plus 27 t over 2 sine 2t over 4 0 to 2 pi. If you substitute the limit, your answer will be closed integral c a dot dr is equal to 9 pi. Remaining thing, you will complete it. This is integration of sine square. You know how to integrate sine square theta. You know how to integrate cosine square theta. So this is the same way. You will calculate the integrals, put the limits, you get that answer. So that is the answer of one side, that is left hand side. Right hand side. So A dot dr is equal to 9 pi. But we have calculated that we have calculated this portion. Its answer is 9 pi. Now let's calculate the second portion, that is the left hand side. Now if you look at the left hand side, it contains, right, the left hand side is S del cross A dot n ds. So you will calculate now this. First thing is calculate del cross A. So del cross A is equal to ijk. Del is delta over delta x, delta over delta y, delta over delta z. And for A, you will be writing 2y here. You will be writing 3x here.
Can I see it here, sir?
Yo बच्चे उबल का बराबर 8 योगदान रहोगे minus z square. So this is I delta over delta x, sorry, delta over delta y of minus z square minus delta over delta z of 3x minus j, and that will be delta over delta x of minus z square minus delta over delta z of 2y plus k delta over delta z, sorry, k delta over delta x of 3x minus delta over delta y of 2y. Now let's calculate it. Thank you. Bas, no problem. Okay. This is equal to 0 because y is z, 0. This z represents 0. This x is z, 0. This y is z, 0. This is x. Answer is 3 y and y minus 2 into k. So your answer is 3 minus 2 is just k. Del cross A is just k. So you have calculated it. This has been calculated. Next thing is, what is n? Now, since the equation of the sphere is given, that is the surface, so we'll say that del of x square plus y square plus z square minus 9, that is a vector which is perpendicular to the surface, so it means it is a normal to the surface. A normal to the surface is the gradient of this quantity, and that is I delta over delta x plus j delta over delta y plus k delta over delta z, and of course it is x square plus y square plus z square minus 9. Okay, so if you calculate it, this will differentiate this only, so you will be having 2xi. This will differentiate this only, you will be having plus 2yja and plus 2zk. If you take 2 common, inside it is x square plus y square plus, it is xi plus yj plus zk. That is a vector which is perpendicular to the surface. Now what is a unit vector? A unit vector perpendicular to the surface will be del phi over del phi magnitude. So it is 2xi plus yj plus zk, and divided by, it will be square of this 4x square, square of this 4y square, square of that, it is 4z square, square root, and that will give me 2xi plus yj plus zk divided by, this 4 becomes 2 out of the this x square plus y square plus z square, right? And this 2 cancel. This gives me xi plus yj plus zk, and square root of this, it will be 3. Okay, if you take square root, it will be 3, and therefore that is 3, that is 3. So you have calculated n. You have calculated n. And what about dx? What about ds? ds, because its projection will be in xy plane. Okay, its projection will be in xy plane. So ds will be equal to dx dy divided by n dot k. This I have explained it when we were dealing with surface integral. Dx will be that, because here there is n is normal to that and k is here. So that is why it is n dot k. Substitute all these things in right hand side. What we get is the following. So your n is this, your del cross A is k, okay, and therefore if you substitute here, okay, del cross A is k, your dot n is xi plus yj plus zk divided by 3 and into ds. ds is dx dy divided by n dot k. n dot k. So I don't need that. Okay, look, this is k dot, so k dot I is 0, k dot j is 0, k dot k is 1, so this will be equal to z over 3 dx dy n dot k. Now again, n dot k means this is your n and k is just k, so n dot k means that this is equal to z over 3 dx dy n dot k mean xi plus yj plus zk divided by 3 dot k, that is n. Okay, so k dot I dot k is 0, j dot k is 0, k dot k is 1, and therefore we will be having z by 3 here as well. Z by 3 dx dy and z over 3 there, from there, z over 3, this will cancel with that, and you will be having dx dy. Now, you are in this plane, and here the value of dx is, r dr d theta. What is r? R is the radius which ranges from 0 to 3, and d theta, it is 0 to 2 pi, it is the angle, because we are here, you are running from here to there, so angle is 2 pi, radius r is 3, so it is 3. So first integrate because of this, so you will be having 0 to 2 pi, and its integration will be r square over 2, 0 to 3 d theta, which is equal to 0 to 2 pi 9 over 2 minus 0 d theta, and that is equal to 0 to 2 pi 9 over 2 out d theta, and that is 9 over 2 theta 0 to 2 pi, and that is 2 pi, 2 to cancel, answer is 9 pi. So we have calculated the answer to this part is also 9 pi, and hence we have verified the theorem for this one. It says verify Stocke theorem for A is equal to this, where S is the upper half surface of the sphere. We have proved that left hand side is equal to right hand side, because we have calculated left hand side, which is 9 pi. We have already calculated right hand side, which is, answer is 9 pi. Hence theorem is verified. Now let's come to the second theorem. The second theorem is also very important, like this. That is Gauss Divergence theorem. G-A-U-S-S, Gauss Divergence theorem. This is second important and very powerful theorem, and its statement is this. Okay, that is mathematical statement. I will just describe it in words as well in a moment. Don't worry. dV is equal to closed integral S A dot ds is equal to, further, because S ds can be written as NDS. No vector sign now on that, because this is already vector, so these two things are equal. Now, if you look carefully, when we were talking about the Stocke theorem, then we said that Stocke theorem interrelates the surface integral and the line integral. Now, similarly, if you look at the Gauss Divergence theorem, it interrelates volume integral and the surface integral. Okay? Here, surface integral is related with the volume integral. In Stocke's theorem, surface integral was related to the line integral. So, this is another theorem which interrelates the surface integral and the volume integral. What it says? Okay, if you have vector A defined over a volume V, which is bounded by the surface S, and surface S must be closed. Now remember that closed surface bounds volume V. For example, open surface does not enclose volume. This is this whiteboard. It is an open surface. It is not bounding any volume. But there are 6 surfaces. If you look at this board, there is a floor, that is one surface, open surface. This is roof, that is also an open surface. Left surface, right surface, they are open surfaces. Front surface, back surface, they enclose the volume, which is the volume of the room, and this is the closed surface. Combined 6 surfaces, they are the closed surface. Okay? Now you look at our skin. This is the closed surface which is bounding our volume. Now if you slaughter an animal and if you open its surface, then what gets out of it is the total meat out of it, and the surface is there, and then it becomes open surface. If you open the surface, you open the closed surface, then you get the volume out of it. So that surface, what I am saying, if you have a volume V on which A is defined and volume V is bounded by the closed surface S, then the divergence of vector A integrated over the volume V is equal to the surface integral of vector A calculated over the closed surface S. It means if you are given a problem to you, by evaluate this, if surface is simple, calculate this. Or you transfer it to that form, you can calculate that, you will get the same answer. Okay? You will get the same answer. So it's up to you. So again, I am not going into proof of this theorem because we are leaving it for mathematicians to do. You should know that there is a theorem of that type which exists. Now I come to a problem, very simple problem, and that is problem 6.94. 6.94, Advanced Mathematics, the book which you have, okay, and it says evaluate. It is, I think, page 190 or something. Let me check. Page 1. Sure. Thank you. बस जमा यो 10-15 मिनट का ठीक है. Okay, evaluate closed integral S A dot N ds. Where A is equal to 2x plus 3zi minus xz plus yj plus y square plus 2zk, and S is the surface of the sphere having center at 3, -1 and 2 and radius 3. Radius 3. Now look, in this problem, they haven't given the equation of the sphere, but they said its center is at here, radius is 3. Last example, he was talking about the circle where its equation was x square plus y square plus z square is equal to 9. Now, the actual equation of the sphere is x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square. Now, this is the general equation of the sphere whose center is at A, B, C point and radius is r. Now, when you say that A 0, B 0, C 0, R is 3, so it means this is a sphere whose center is at the origin 0, 0, 0 and radius is 3. And this is a sphere whose center is at A, B, C and radius is R. Now in this case, you have a sphere whose center is at 3, -1 and 2, A is 3, B is -1, C is 2, radius is 3. So you can make the equation. Okay? Don't worry about that. Let's see how this figure looks like. This is x, this is y, this is z. Now, if you are talking about a sphere whose center is at the origin, you can have a sphere there and let this point be at the center. But it is not saying. It is saying that at x is equal to 3, y is equal to -1, and z is equal to 2, 1 unit and 2 unit. So that is the place where center of the sphere is. So you will be having something like this. That is, this is the center of the sphere, 3, -1 and 2. Okay, and how much is the radius? Radius is 3 unit. Okay, so that is. Now let me explain how you get it. How much is the value of x? 3 unit. You will have 3 unit there. And he says y is -1, you will go to the back 1 unit. And then, well, let's say this is the back of the other portion. So that is, x is, well, it can't be back. Okay. So back is -1 there. On the other side, then you go 2 units up. So at that point, whatever point you get, you make your sphere of radius 3. So that is like that one. Okay, so this is how we explain that. Now you can, it doesn't say verify the theorem. You know, last problem we said verify Stocke theorem. Now we say evaluate this. Now we say evaluate this. Now it is up to you whether okay. So it is up to you whether you calculate this side or this side. Of course it is given, but since theorem says that this side is equal to that, so it will be easy to calculate that. So first of all, you say since closed integral s a dot n ds is equal to triple integral volume integral del dot a dv, and therefore it is del dot a is equal to I delta over delta x plus j delta over delta y plus k delta over delta z dot a, which is 2x plus 3z I minus xz plus y j plus y square plus 2z k, and that is bracket closed. I dot I is 1, so delta over delta x of 2x plus 3z, I dot j 0, I dot k 0, plus j delta over delta y, j dot I 0, j dot j is 1, so this is minus, so I'll put minus sign there. Okay, so j dot j is 1, so delta over delta y into xz plus y plus k dot I 0, k dot j 0, delta over delta z, k dot k 1 of y square plus 2z. Calculate that. This differential will be 0 because it is to x, so you will get 2. Here this will be 0 and answer is minus y minus 1, because delta over delta y is 1 minus I. Delta over delta is plus 2 because this is 0, and you get that. 2 plus 2 is 4, answer is 3. So therefore triple integral v del dot is 3 dv. So 3 can be taken out of the integral dv. Now if you calculate that, it will give you v, which is volume of the sphere. It is volume of the sphere, which is given to you. Okay, and you know what is the volume? It is 4 by 3 pi r cube. So 3 cancel. 4 pi. What is r? Which is 3. It is 3 cube, and so it is 4 into 27 into 27, because 3, 27 pi 108 pi is the answer. 108 pi is the answer. This is how it is calculated. Now I come to one last question, which will, make this theorem more clearer than like the previous one. The last problem. Verify Gauss Divergence theorem. Verify. Gauss's divergence theorem for vector A is equal to xi plus yj plus zk over the cylinder shown in the figure. Now in this case, equation is not given and figure is part of the problem. Figure is given to you and figure is like this. A cylinder is given. He says h is its height and r is a is its radius. This is y, this is z, this is x. In this problem, figure is given to you. You don't have to plot the figure. And it says verify the Gauss theorem for A is equal to this over the cylinder shown in that. So you will say now the same thing. V del dot A dV is equal to closed integral S A dot N ds. Now in this case you have to calculate all the three parts. So for left, that is, you will calculate left hand side and right hand side, because he is saying verify the theorem. Unlike the first thing where he said calculate that, so you can use either this possibility or you can use that with the help of theorem. But now he's saying you have to verify, so you have to calculate both sides. So left hand side is del dot A dV. Calculate del dot A. Now it is easy because A is this. So delta I delta over delta x plus j delta over delta y plus k dot that thing. So from here, if you calculate it, then del dot A will be your equal to 3. And if you calculate this thing, then you will be having V 3 dV, and 3 is common, so it is dV. dV is the volume of the cylinder. It will be 3V, and V is the volume of the cylinder, which is equal to 3, you know what volume of the cylinder is, how much? It is pi a square base into height. It is pi a square into h base into height, and that is answer is 3 pi a square h. Okay, this is how you calculate it. Now, in order to prove that this cylinder consists of 3 surfaces, so if you calculate this portion, right hand side, then it will be equal to number 1. Calculate over upper surface S1, lower surface S2, curved surface S3. So S1 A dot N ds plus S2 N dot ds plus S3 N dot ds. Now it is easy, because if you are talking about the upper surface, then A is this one, this is A, and what is N? N is normal, which is K. So you calculate that. For the lower surface, your this is A dot NDS. A dot NDS A dot and ds. So if you calculate that, A is there and n is minus k, and here you will calculate this for lower surface, n is minus k. Okay, now if you calculate this A dot n, so it will be z. Okay, so here you will be having z and then ds, and of course you will be having dx dy. You calculate this surface integral. For lower surface, if you calculate A dot this, you will be having minus z, but in the lower surface, z is equal to 0 at lower surface. And here you will calculate n from the equation of that. You will calculate n from the calculation, and n will be equal to xi plus yj divided by x square plus y square square root, which is equal to xi plus yj over a, because that is the radius. So calculate this and you will see the answer from this part is equal to pi a square h. Answer from this part will be equal to 2 pi a square h, and answer from this part is 0, and if you add these you will be having a square h, which is the same as this one. Okay, so I have left something for you to calculate, calculate the surface 3 integral. If you have any problem, you can ask me on the WhatsApp and I can help you. This is I have left for you to complete it, because I am not supposed to do every and each step. These are simple. You have studied that in the previous 2-3 lectures, and now you should apply those ideas here, and you say, and that is how you will complete the problem. Okay, thank you very much.